Okay, today we shall be developing a short run and long run causality model. Using VECM. That is our target. And here we have three variables, such as you can see from here: cons, EX, and GDP. What is cons? Cons means consumption. That is one variable. Then EX means EX is the second variable, is export. And the third variable is GDP, meaning that gross domestic product. So that is our three variable here. And here the variables are here: cons, EX, and GDP. And so what I do, I open as a group all the variables. So the three variables, GDP, cons, and export. So it is starting from 1960. You can see from here, from the 1960, starting from 1960 until 1995. From the 1960 until 1995. So, and here we assume that all our three variables are integrated of same order, meaning that at level they are non-stationary, but when I convert them to first difference, suppose, then they become stationary. That I assume without checking. And the thing is that when the variables are integrated of same order, when the variables are integrated of same order, we can run the Hossain test of cointegrations. Okay. So Hossain test of cointegration. When the variables are integrated of same order, we can run the Hossain test of cointegration. So what I do, I go to quick, then group A statistics, then I choose Hossain test of cointegration. Okay, so here I put all the variables. first is cons, then export, then GDP, then so these are all variables, and these three variables are not stationary, meaning that they have unit root. They have unit root at level, right? So then I proceed, I go to OK. So here I choose the 3, right? And here I choose the lag, I choose the 2. I choose lag 2. Why I choose lag 2? Because lag selection criteria is asking me to take lag 2 for this system equation. So I'm telling again, lag selection criteria is asking me, suppose, to choose lag 2, and that is why I have chosen here lag 2, right? Okay, then I proceed, then I choose here 3, right? I choose here 3, then I proceed. So this is the outcome of the Hossain test of cointegrations. So here are 3 variables, right? And here you can see, so this is the null hypothesis, meaning that there is no cointegration. There is no cointegration, that is called none. And here what is happening? Trace statistics is more than critical value, meaning that we can reject this null hypothesis. And also the probability value is less than 5%. So when the probability value is less than 5%, we can reject the null hypothesis, meaning that none. What is none? There is no cointegration among 3 variables. Then what about here? At most 1, meaning that there is one cointegrated, there is one cointegrated equation, that is null hypothesis, and that is at most 1. There is one cointegrated equation or one error term, that is called at most 1. That is called at most 1. And here the trace statistics is 8.40 and critical value is 15.49. So here that trace statistics is less than critical value, so we cannot reject null hypothesis. Rather, we accept null hypothesis, meaning that at most 1, meaning that there is one error term, there is one cointegrated or one error term exists in the model. And also p-value is how much? 42.34%. It is here how much? The value of p. From here the p-value is 0.4234, meaning that 42.34%, which is more than 5%. So we cannot reject null hypothesis. rather we accept null hypothesis, meaning that at most one, meaning that there is one error term, meaning that all the variables are co-integrated. All the variables are co-integrated, meaning that all the variables such as cons, export and GDP have long run associationship. And also here the trace statistics indicate one cointegration model at the 5%. The result is already mentioned here of this trace statistics. Okay. Then we talk about the second statistics, maximum eigenvalue test, and here what is happening? Maximum eigenvalue test, right? Okay. And here what is happening? I can see here what is the null hypothesis? Number of co-integrated. What is the null hypothesis here? Number of CE. What is C? C means cointegrated equation. That is called CE. Number of co-integrated equation. That is the null hypothesis. Okay, what is the null? First I choose none, meaning that there is no co-integrated equation. What is none? There is no co-integrated equation or no error term. So that is the null hypothesis. And here what is happening? Max eigen statistics is 48.61 and critical value is 21.13%, meaning that max eigen statistics is more than critical value. So we can reject the null hypothesis, meaning that we can reject this none. Then the second thing, the probability value, the p-value is how much? It is less than 5%. So when the p-value is less than 5%, we can reject the null hypothesis, meaning that we can reject none. Okay, then our second null hypothesis, at most one. So meaning that there is one error term or there is one co-integrated model. That is the null hypothesis. And here the max eigen statistics is 8.31, but critical value is 14.26. As a result, max eigen statistics is less than critical value, meaning that we cannot reject null hypothesis. Rather, we accept null hypothesis, meaning that at most one is true. At most one is correct, meaning that all the three variables are co-integrated, meaning that they have long-run associationship. And also probability value, the p value is how much? 34.73%, which is more than 5%. So we cannot reject null hypothesis, rather we accept null hypothesis, meaning that there is at most one cointegrated model is there, or there is one error term exists in the model, meaning that all the three variables have long run associationship. And the result is given here also. Max eigenvalue test indicates one cointegrated model at 5% level. So what is happening here? According to the test statistics, all the three variables are cointegrated, and also maximum eigenvalue test also telling the same thing. That is all the three variables have long run associationship. So meaning that we can run the vector error correction model because all the three variables are cointegrated. So we can run the vector error correction model. Okay, and here what is happening, and also it is the long run model, long run cointegration model, it is here. So it is the dependent variable cons, and ex is the independent variable, and minus 34733 is the coefficient, right? And it is the standard error, and it is the coefficient of GDP and standard error. And here this coefficient actually long run coefficient, not short run, because this whole model actually is long run model, long run cointegrated model. So the coefficient, this coefficient minus 3.47 and this coefficient minus 6.37, these two coefficients are long run coefficient, not short run. And here what is happening, the sign is negative, meaning that when export goes up, consumption goes down, or when export goes down, consumption goes up in the long run. And here what is happening, the coefficient is negative, meaning that when GDP goes up, then consumption goes down, or when GDP goes down, then consumption goes up. So that is the outcome of this long run model, long run cointegrated model. And the thing is that, but what is happening here? If the export goes up, then consumption should go up or go down. That is the question. And the second question is that if the GDP goes up, consumption goes up or goes down. So that is another question, right? But normally when the GDP goes up, then consumption should go up, and when the GDP goes down, consumption should go down. That means the sign should be positive, but here it has been negative. right? Here it has been negative, but the sign should have been positive. And then what about here? If the export goes up, then probably consumption may go down, right? Or sorry, when the export goes up, meaning that our consumption also goes up. That means the foreign consumption. Suppose, yes, when export goes up, then consumption also goes up, and when export goes down, consumption should go down. That means the sign should be positive here. The sign should have been positive, but here it has been negative. So that is the weakness. So I am writing here, that is the weakness of this long run consumption model. Long run consumption model. That is the weakness of this long run consumption model. Okay, so however, as all the three variables are co-integrated, as all the three variables are co-integrated, we can run the VECM model. Okay, as the three variables are co-integrated, we can run the VECM model, right? That we can run. Okay. Then we can run the VECM. So I go to quick. Sorry, I take it out. I go to quick, then estimate var, right? And here I choose VECM, that I choose, and here the co-integration. Okay, so here the number of co-integration model is how much? 1. So it is already 1 is there, and the last time I choose number 3, and also I choose here number 3, right? The same thing, I'm choosing the same thing. So I choose the 3, right? Then I first put dependent variable, that is cons, that I do first, then GDP, and then I put export. So here what is happening? So the cons is the dependent variable, and GDP and EX is the independent variable. So cons, GDP, and EX. And here I have chosen lag2, like Johansen test of co-integration. So here I am choosing lag2 as before. I am choosing lag2 as before, like Johansen test of co-integration. We chose lag2, and here I am also choosing lag2 because both model are system equation model. So I should use the same lag. So here I am choosing lag2, and so I can run the model. So this is my outcome of the vector error correction model, right? And here cons is the dependent variable, meaning that consumption is the dependent variable and GDP and export are the independent variables. So the first one is this model, cointegration model, right? That is the number one. One cointegration model is there. And here there are three variables, dcons, dGDP, and dx. So it is the dependent variable, dcons, and so that is the dependent variable. And the first variable actually our target. Our target model is the first one, not the second or third one. Our target variable is the first one, dcons. That is our target variable, right? Because here the consumption is the dependent variable. So the first one would be our target variable, not the second one or third one. This one should be our target variable. But here what is happening, suppose I talk about this one, 37.51. Actually it is the coefficient, and then and it is the coefficient of this variable, and it is the standard error, and it is the t value. It is the t value, but here is no p value. Here is no p value. So but I want to know what is p value. I want to know what is p value for each variable. Okay, so to know p value, I use the system equation to know the p value of each variable. System equation. Okay, so then what is the system equation? Okay, so system equation, I go to proc, then I choose max system, right? That is system model, max system, then order by variable that I choose, then I press order. Okay. So yeah, so here you can see our three model. One is dcons, the dependent variable, and dGDP, that is our dependent variable, and dex is another dependent variable. And you can see it is starting from C1 until C24, because the whole thing actually is the system equation model, and it is starting from C1, then C2, C3, then C16, C17, C21, then C24, right? System model. Okay, and here you can see three model number 1, model number 2, and model number 3. Out of these three model, the first model is our target model, because the cons is the dependent variable. So that is why the first model is our target model. And you can see from here to here, what is it? from here to here? What is it? From here to here, actually we call it, sorry, from here to here we call it cointegration equation, cointegrating equation. Cointegrating equation when cons is the dependent variable, right? So from here to here we call it cointegrating model when cons is the dependent variables, meaning that from here to here the error term is here, meaning that from here we can get what? I'm writing here. From here we can derive the residual of the cointegrating equation when cons is the dependent variable. From here means from here to here, right? From here to here. From here to here. From here we can derive the residual of the cointegrating model when cons is the dependent variable. Okay, the second step is so what I do, I select our target model. I select it. I select that our main model. I select and copy. I copy it and go to the quick estimate model. I go there and I paste it. Here I paste our target model. This is our target model, right? This is our target model, and I press OK to estimate this model. Actually, what is it? We want to estimate our target model. So I press OK. So this is the outcome of this model, right? So here the model, you can see consumption is the dependent variable, right? That is our model is here. Okay, now here we have the short run and long run causality is here. Short run and long run causality is here. How? Okay, so suppose what is C1? C1 actually this one, the coefficient of the cointegrated model. That means this is cointegrated model, right? From here to here. So C1 is the coefficient of this cointegrated model. So meaning that from here to here until this cointegrated model, so that is C1. And C2, C3, C4, C5, C6, C7, meaning that here C2, C3, C4, C5, C6, C7. So these are all short run coefficient, right? These C2, C3, C4, C5, C6, C7 are short run coefficient. Okay. But you know what is C1? C1 is actually C1 actually I call it, just I'm writing here. C1 means actually here, C1 is what? Speed of adjustment. Speed of adjustment towards long run equilibrium. Equilibrium. Speed of adjustment towards long run equilibrium. But it must be significant. It must be significant, and the sign must be negative. So, but here the coefficient is not negative, but it is significant. It is significant because the p-value is less than 5%, but the coefficient is not negative. So meaning that the coefficient is not negative, meaning that there is no long run causality. There is no long run causality. There is no long run causality from the two independent variable such as GDP and EX. So meaning that our two independent variable such as GDP and EX have no influence on the dependent variable such as cons in the long run. In other words, I can say, there is no long run causality running from GDP and export to cons. So that is the outcome of this result, right? There is no long run causality running from GDP and export to consumption. Why? Because the sign is not negative. The sign is not negative, right? The sign should be negative and it must be significant. Yes, it is significant, but the sign is not negative. So we cannot accept the result. What is the meaning? Meaning that there is no long run causality running from GDP and export to consumption. So that is the outcome of this model. Okay. Then I talk about short run causality, right? I talk about short run causality. So then I talk about short run causality. Short run causality, meaning that whether whether GDP and export have short run causality or not. So okay, so first I check with the GDP. First I check with the GDP whether there is a short run causality or not. Okay, and here you can see GDP has C4 and C5. Here are two coefficients, C4 and C5, and here I shall be using the wall statistics, right? Wall statistic to check the short run causality from GDP to consumptions. From GDP to consumption. And here, what is our null hypothesis? Should be C4 equal to C5 equal to 0 or not. That is the null hypothesis. If I cannot reject null hypothesis, if I fail to reject null hypothesis, meaning that C4 and C5 is 0, meaning that there is no short run causality running from GDP, running from so meaning that there is no short run causality running from GDP to consumption. If they are 0, meaning that there is no short run causality running from GDP to consumption. Okay, so we run world statistics now, right? World statistics now. Okay, so I go to view, then residual, coefficient diagnostic. I choose this one, then world test, right? World test I choose. Okay, then what is our null? Should be C4 equal to C5 equal to 0, right? So that is our null hypothesis. Then I proceed with the null hypothesis. It is the world test, right? And it is our null hypothesis. C4, C5, 0. And here I choose the chi-square statistics and corresponding p-value. The p-value is very small. How much is the p-value here? The p-value is around, p-value becomes 0.0008, meaning that meaning that less than 5%, meaning that 0.08%, and that is less than 5%, meaning that we can reject the null hypothesis. We can reject our null hypothesis, meaning that C4 and C5 is not 0, meaning that C4 and C5 is not 0, meaning that there is a short run causality from GDP to consumption. So there is a short-run causality from GDP to consumption. Okay, so then we have some more model, right? So and we have another variable. The second question is whether whether there is a short-run causality from export to cons. So that is our second question, whether there is a short-run causality from export to cons. So that is our second question. And what is the result of the second question? You can see from here. So here, what is C6 and C7 are the export variable. So what should be our null hypothesis? It should be whether C6 and C7 is 0 or not. That is our null hypothesis, right? And here we shall use the world statistics as before. We shall use the world statistics. How? I proceed with the world statistics. I go to view as before. Then I go to coefficient diagnostic. Then I choose world test. C6 equal to C7, right? That is our null hypothesis. C6, C7. Then I press OK. It is the result has come up, world test, and it is the null hypothesis. C6, C7, 0, and chi-square value and corresponding probability. So the value is very small, less than 5%. So we can reject the null hypothesis, meaning that C6 and C7 jointly are not 0, meaning that C6 and C7 are not 0, So meaning that, what is the meaning of it? Meaning of it, there is a short-run causality running from export to GDP. Okay. So what is our decision of the whole model? What is the summary of this model? The summary of this model is okay, number one decision, there is no long run causality from GDP and export to consumption. So there is no long run causality from GDP and export to consumption. So that is the first decision. And what is the second decision? There is a short run causality from GDP and export to consumption. So that is the second decision of this model that there is a short-run causality from GDP and export to consumption. Okay, so that is the final summary of this model. Okay, then finally we check. Then finally I check whether our model where consumption is dependent variable, whether our model where consumption is dependent variable has any statistical error or not. Okay. Okay. So actually this one actually our main model, right? Consumption is the dependent variable. Okay, and here what is happening? Whether our model where consumption is dependent variable has any statistical error or not. Okay, so first I check R square. R square is how much? 63.39%. So so the value of R square is quite high. So we are happy about the model because the value of R square is 63.39%. And what about the F statistics and the corresponding probability? Yes, the F statistics is significant. So we are also happy about this model. Then finally we check I go to view, I go to the residual analysis. So first I check serial correlation, right? Serial correlations. So I choose lag 2, and here you can see the serial correlation, but the thing is that the p-value is less than 5%, meaning that we can reject the null hypothesis, meaning that this model is suffering from serial correlation. So that is not desirable for a model because we can reject the null hypothesis. So meaning that this model has serial correlations. So that is not a good sign of this model. Then we can check about residual diagnostic. We can check about test of this one. We can check this one, Heteroscedasticity Test. And here I choose the Bruch-Bregan, right? And here you can see that I choose the observed R square, right? And what is the p-value? P-value is 44.11%, meaning that this model does not have heteroscedasticity. So that is a good sign of this model because this model does not have heteroscedasticity. Then finally I check the test of normality, right? That is the third one, test of normality. And here I check the Jarkabera statistics and the p-value. How much is the p-value? 96.72%, which is more than 5%, meaning that the residual of this model, is normally distributed, and that is what? That is desirable. that is desirable. So in this model there is only one problem. There is only one problem, that is the residuals are serially correlated. That is the only one model. That is the only one problem of this model, and that is not desirable at all. That is not desirable at all, and we cannot accept this model because the residuals are serially correlated. That is really bad. Okay, so last time I chose consumption as a dependent variable, and GDP and export were independent variable. But this time I shall choose GDP as a dependent variable, and the rest too, such as cons and export as independent variable. Okay, and now I shall run the vector error correction model. Why? Now I shall run the VECM model. Why? Because all the three variables are co-integrated. Okay, then I proceed like before. I go to quick, then estimate var, and I choose vector error correction model, and this time GDP is the dependent variable, and the cons and export are the independent variable, right? So this is our model, GDP, cons and export. So I press OK, and last time I chose lag 2, so this time also lag 2. Okay, so this is my model, right? This is my model, and this is the co-integrated model. And here the first one actually our target model. The first one is our target model because the GDP is the dependent variable. But the problem is that here is no p-value. Here is no p-value. So to see the p-value, I use system equation, right? So system equation, meaning that, so I go to proc and make system order by variable, then okay, and here you can see we have three model. That is, one is the dGDP, that is dependent variable. Dcons is also dependent variable, and dx also dependent variable. But the first model actually our target model, because now the GDP is the dependent variable. And here, from here to here, from here to here, this one actually called the residual of the cointegrated model. This one is the residual of the cointegrated model, or the cointegrated model. Actually, this one is the cointegrated model, and from this cointegrated model we can get the residual. From this cointegrated model we can get the residual also. Okay, what I do, I copy the whole model, our model, where the GDP is the dependent variable. I copy it and I go to quick estimate model, right? Then I paste our target model. So that is our model where GDP is the dependent variable. Then I press OK, and this is our outcome. Result has come up, right? And here you can see the C1, actually this one is the error correction term, or the coefficient of the error correction model. C1 is the coefficient of the error correction model. And here what is happening, C1, the coefficient is negative, and also the probability is less than 5%, meaning that C1 is significant. So here what is happening, the C1 that we are talking about, the C1, what is our model? Sorry. Yes, yes, this model, sorry. C1, just 1 minute. I'm taking it. I'm making it adjusting. Okay, 1 minute. Okay, not this one. Not this one. It is here, I guess. Ah, yes, yes. I make it small slightly. Yes. Here you can see from here C1, right, which is a negative sign and also significant. Negative sign and also significant. Meaning that there is a long run causality. There is a long run causality running from cons and GDP, sorry, cons and export to GDP. So the C1 is negative sign and also significant, meaning that there is a long run causality running from consumption and export to GDP, meaning that from here, from consumption to and export to GDP. Why? Because the sign is negative and significant. Okay, and what about the short run causality? What happens there? Short run causality. So the first is I talk about decons. I talk about cons, right? That means it is C4 and C5. So what should be our null hypothesis? Our null hypothesis whether C4 and C5 is 0 or not. That means it is C4 and C5. And here we shall use world statistics as before to check short run causality. To check short run causality. Okay, so I go to view, then I go to coefficient diagnostic, wall test, right? Wall test. Okay, and what is our null? C4 equal to C5 equal to 0. Sorry, that means they are jointly 0. That is our null hypothesis, right? So I press OK. So it is the result of wall test and it is the null hypothesis. C4, C5 is 0 and chi-square value. And what is the probability value? The probability value is less than 5%. So meaning that we can reject null hypothesis, meaning that C4 and C5 jointly is not 0, meaning that C4 and C5, meaning that meaning what? What is our model? Meaning that C4 C5 means what? C4 C5 means, I check from here, C4 C5 means consumption, right? C4 and C5, you can see here C4 and C5, meaning that C4 and C5 not 0, meaning that there is a short run causality running from consumption to our dependent variable, which is GDP, right? So there is a short run causality running from consumption to GDP. Okay, then our last variable, export. Export is our last variable, and you can see from here C6 and C7, right? These are our two variable coefficient, and for export, what is our null hypothesis? C6 and C7 equal to 0. That is our null hypothesis that we have set, right? That is the null hypothesis we have set. Okay, so then I go to view as before, coefficient diagnostic, wall test. So I put C6 equal to C7 equal to 0. That is our null hypothesis. C6, C7, 0, and the result is coming up. Okay, it is the null hypothesis, C6, C7, 0, and chi-squared. The p-value is very small, less than 5%, meaning that we can reject null hypothesis, meaning that C6 and C7 jointly are not 0, meaning that they are not 0, meaning that there is a short run causality running from export to GDP. There is a short run causality running from export and GDP. Okay, so what is the summary of the model? What is the summary of the model? What is the summary? The summary is a summary of the model. Sorry, number one summary. There is a long run causality running from EX and cons to GDP. There is a long run causality running from EX and cons to GDP. And also there is a short run causality running from EX and cons to GDP. So that is the summary of this model. Okay, now the third thing is whether the model is statistically all right or not. Statistically all right or not. So that is the thing. Statistically okay or not. So what is our model? This is our model, right? GDP is the dependent variable, right? So statistically all right or not. Okay, here the R squared is 61.39%. So the value R square is not that low. At the same time, it is not that high, but we are happy about it. At least it is more than 60%. So we are happy about it. And the F statistics is significant. F statistics is significant. So we are happy about this model. Okay, then what about the test of residual? First I check about serial correlations, right? Okay, here this is observed R square. The p-value is very small, less than 5%, meaning that this model has serial correlation. So we are not happy about this model because this model got serial correlation. That is not desirable. Okay, then we check some more test, residual diagnostic. We check the test of heteroscedasticity. So I check it. Then observed R square. The how much is the value of p? The p value is 41.29%. 41.29%, meaning that more than 5%. Meaning that we cannot reject null hypothesis. Meaning that there is no heteroscedasticity in this model, and that is desirable. And that is desirable for this model because there is no heteroscedasticity. And finally, I check about the test of normality. So that is our third one, test of normality. You can see the Jarkabera statistics and corresponding p-value. How much is the p-value? It is p-value comes up, it is 88.24%, right? Which is more than 5%, meaning that we cannot reject null hypothesis. So meaning that the residuals are normally distributed, meaning that the residuals are normally distributed, and that is desirable. So in this model there is only one problem. In this model there is only one problem, and that is this model got serial correlation, and that is not desirable. This model got serial correlation, and that is not desirable. And that is the only problem of this model. Okay, so last time, last time I chose consumption and GDP as dependent variable, but this time I shall choose export as dependent variable. Export as a dependent variable. Okay. So I go to quick, then estimate var, then I choose vector error correction model because all the variables are co-integrated. So I put export first as a dependent variable, then cons and GDP as a independent variable. So that is our model, and export is the dependent variable. Consumption and GDP are independent variable. Then I run the model. This is our vector error correction model, right? You can see. And the first model actually our target model. The first model is our target model because export is the dependent variable. But here is no p-value. So I go to proc, I go to make system, order by variable, and the first model actually our target variable. This is our target variable. So I copy it, I copy the whole thing, then I go to quick, then estimate model, then I paste it. So this is my model, right? This is my model, and I press OK. So this is the result of the whole model comes up, right? This is the outcomes of the model. And here you can see that is C1. What is C1? C1 is the coefficient of the error term, that is C1. The sign is negative and also it is significant. The coefficient sign is negative and also significant, meaning that meaning what? Meaning that why is the model? Okay, yes, here I come back here. Okay, meaning that I'm saying what? C1 is negative and significant, meaning that there is a long run causality running from GDP and GDP and consumption to export, right? Why? Because the C1 is negative and significant. So there is a long run causality running from GDP and consumption to export. It is our export, right? It is our export, and the export is the dependent variable. Okay, now I talk about short run causality as before. Short run causality using world statistics, right? World statistics and short run causality. Okay, so first I talk about this one, the cons. That means C4 and C5, right? C4 and C5. So the first I talk about cons, right? Which is there are two coefficient, whether C4 equal to C5 or not. And that is our null hypothesis, whether C4 and C5 jointly are 0 or not. That we want to check. That we want to check using world statistics. Okay, I go to view, then I go to coefficient diagnostic, then world test, right? Then I put C4 equal to C5 equal to 0 or not. That I check, C4, C5. Okay. Then I press OK. Here the wall test, and how much is the probability value? Less than 5%, right? Less than 5%. So we can reject our null hypothesis, meaning that C4 and C5 are not jointly 0. They are not 0. Meaning that there is a short run causality running from consumption to export. So that is the decision. So what is the thing? The decision is there is a short run causality running from consumption to export. Okay, then our second variable is what? Second variable is GDP, right? Second variable is the GDP, and what is our model? This is our model. So what is GDP? C6 and C7. You can see from here, C6 and C7. So in case of GDP, the null hypothesis is C6 equal to C7. Sorry. Is it 0 or not? That is the null hypothesis. C6 and C7 0 or not. That is our null hypothesis to be tested. So I go to view as before, then I go to coefficient diagnostic, then world test as before, then I write C6 equal to C7 equal to 0, right? That is our null hypothesis, right? C6 and C7, right? Okay, world test, and it is the null hypothesis, C6, C7, 0, but the p-value is very small. It is less than 5%, so we can reject null hypothesis, meaning that C6 and C7 jointly are not 0. So meaning that there is a short run causality running from GDP to export. So there is a short run causality running from GDP to export. Okay, so what is our summary of this model? What is summary of this model? The summary of this model is number one, there is a long run causality running from GDP and cons to export. So that is the first summary. There is a long run causality running from GDP and cons to export. And And what about the second summary? There is a short run causality running from cons and GDP to export, right? So this is the summary. This is the summary of this model. Okay, then I check the statistical point of view. Statistical point of view, right? Statistical point of view about this model, right? Statistical point of view. So these are model, right? Statistical point of view. What is happening here? So this is our model, and export is the dependent variable. And here R square is how much? Oh, it is very low, only 43.77%. So we are not happy about it. But the thing is that F statistics is significant because the value is less than 5%. So we are happy about it because F statistics is significant. Okay, then I go to view, then residual diagnostic. I go to serial correlations. So I press OK. Okay, you see the observed R square, the value of P. What is the value of P for this model? I can check from here. The value of P of this model is the P value is 0.3559, meaning that 35.59%, which is more than 5%, meaning that we cannot reject null hypothesis, meaning that this model does not have any serial correlation. So we are happy about this model because there is no serial correlations. Then we talk about the residual diagnostic, talk about the test of heteroscedasticity, right? And here I choose this test, press OK. Okay, the observed R square, how much is the P value? P value here is coming, P is coming how much? 19.81%. P is 19.81%, meaning that more than 5%, meaning that this model does not have any heteroscedasticity, meaning that there is no heteroscedasticity in this model. So we are happy about this model. Excuse me. And finally, I check the test of normality of this model. Test of normality. I go to view, then residual diagnostic, test of normality. It is here. You can see the Jarkabera statistics and corresponding P value. How much is the P value for this model? 24.13%, which is more than 5%. So we cannot reject null hypothesis, meaning that the residuals are normally distributed, meaning that the residuals are normally distributed. So for this model, everything is fine. There is no serial correlation, there is no heteroscedasticity, and the residuals are normally distributed, and the F statistics is significant. So all are good. All are good for this model. So we are happy about this model.